So here we are back for part B of the video with hopefully the technicals sorted out. If we carry on, we've got minus 5 over 4 is equal to 20 tan alpha. Of course, the u's cancel in that first bit, and sine alpha over cos alpha is tan alpha. And the back end of things, u squared is from the first part 2g over sine squared alpha. So this is a half g multiplied by 400 over u squared. So remember that u squared is 2g over sine squared alpha, and then on the denominator is cos squared alpha as well. So it's all a bit messy there, but this then simplifies into minus 5 over 4 is equal to 20 tan alpha minus 100 tan squared alpha. Okay, so you need to do a bit of work just to satisfy yourselves that that's the case. And if we then, this is a quadratic equation, of course, which we can put into the calculator, and we get that tan alpha is equal to 1/4 or minus 1/20. Well, we know tan alpha, we know alpha has to lie between 0 and 90 degrees, so it can't be negative. Tan alpha can't be negative, so therefore alpha is equal to the inverse tangent of 1/4, which is 14.0 degrees to 1 decimal place. And C, state one limitation of the model that could affect your answer. Well, we've ignored air resistance and also things like spin, which would take it off track. So we ignored air resistance and spin. So either one of those would be sufficient. And part D, find the time taken for the ball to travel from A to T. Well, horizontally, we know that T is 20 over u cos alpha, and u squared is 2g over sine squared alpha from previously. So that means that u squared is 334.9. We have all of those values, so therefore u is 18.3 meters per second. And if we substitute that back into the equation that we've just got from here, so substituting that back into there, t is equal to 20 divided by 18.3 cos alpha, which is 1.13.